Hello, physical scientists. Ms. Getz here, and today we're going to talk about taking our speed equation even further so that we can use that equation to calculate distance or time. So your goal by the end of this video is that I can calculate the time or distance for a moving object using the speed equation. So to start off with, we have our speed equation here. Speed is equal to distance divided by time. If I want to calculate the distance something goes, I'm going to have to get distance all by itself. And so take a moment right now and try to decide, how could you get distance all by itself? So maybe you thought that we should isolate distance in the equation. That means getting rid of this time that's hanging out on the same side of the equation as distance is. So to do that, from math class, you recall that you can multiply the equation times that thing. So I'm going to multiply by time. And if I do that to one side of the equation, I have to do that to the other side of the equation as well. So multiply by time on both sides. And you might recall from math class that if I have something on the top of an equation and the bottom, on the numerator and the denominator, it's the same thing. They'll cancel out and go away. So time disappears. And we end up with the equation that distance equals speed times time. I can rewrite that. Time times speed equals distance using just letters. Either format is good. So this algebra process is a good one to understand. And if you feel like, yeah, I got this, that is awesome. But in physical science, we're actually going to give you the equation. So I'm going to give you my speed equation. I'm going to give you the distance equation. I'm going to give you the time equation. Anytime you're going to need to use them, we'll have these equations for you. Being able to understand and go through the algebra to make the equations yourself is a great thing. But here in physical science, we don't want to test your math skills. What we want to test is your ability to use math to solve problems. And so we're always going to give you these equations. And notice that I can write them as words or letters, and either one is just fine. So let's try a sample problem together. Osman is playing soccer with his teammates and runs down the field for 5 seconds to pass the ball to his teammate 2. Osman has an average speed of 3 meters per second. How far did Osman run? Take a moment right now and try to determine what you know and don't know in this problem. Awesome. So hopefully you recognized that we know 5 seconds is the amount of time because it's measured in the unit seconds. And we also know this other thing, 3 meters per second, and it's in meters per second. And also I can see the word speed right before it, so that tells me it's a speed. And finally, we want to know how far Osman ran, or how far did Osman run. So that means we're looking for the distance. Whew. Okay, so we know we're looking for the distance, we know the time and the speed, and we have to decide which equation to use. Take a moment and decide which equation we should use to solve this problem. Hopefully you agree with me that we should use distance equals speed times time. So I'm going to go ahead and write down that equation. And again, you can write it down in words or just in letters algebraically. Either one is fine. And now I know what equation I'm going to use. So then I'll show my work, writing down that the distance will equal 3 meters per second. That's my speed, Osman's speed, times 5 seconds, how long he was running for. And we can then determine how far he ran. We get a distance of 15. What units should I add on? Remember, that last step is adding those units, and it's a really important one. So take a moment, think for yourself. If we're measuring the distance that Osman ran, and it's 15, see if you can figure out what those units should be. And hopefully you decided that the units should be in meters. And a great way to figure out what your units should be is look back at the speed. The speed is in meters per second. So that means it's telling me about how many meters we go for every second. So any distance it measures or distance it describes has to be in meters. Awesome. Okay, so this problem, not so bad. Let's try one more. And here we have Sarah is biking to school and can bike with a speed of 15 miles per hour. Her school is 10 miles from her house. How long will it take her to bike to school? Whew. You should have turned your phone silent, Ms. Getz. Sorry, guys. So I want to go through and figure out what are my knowns. Well, 15 miles per hour. That must be a speed, and we can also tell it's a speed because it has the word speed right before it in the sentence. So 15 miles per hour. And notice that I changed how that was written to make it a little shorter so that it's MI. Again, the division sign is per, and then hour abbreviated HR. Then the other number is 10 miles, and that is our distance, so 10 miles away. And finally, how long will it take her to bike to school? This one's hard because it says how long, and you usually think of like lengths as like a distance. But the confusing thing about the English language is that we often say how long when we're referring to time. Like I might say, how long do you brush your teeth for? And you would tell me how much time it takes you to brush your teeth. English is confusing. So how long will it take her to bike to school means that we're looking for the time, the amount of time Sarah is biking to school for. So we know the distance, we know the speed, and we're looking for time. So now I have to decide, step 2, which equation should I use? Take a moment and try deciding which equation you would use. And hopefully you agree with me that we should use the equation time is equal to distance divided by speed. So again, I'm going to write that down, and you can write it down in letters, T equals D over T, or in words. Either one is fine. You don't have to write it down both ways. So then I'm going to go to my next step, and I'm going to show the work for my calculation that time will equal 10 miles divided by the speed of 15 miles per hour. Okay, I'm going to plug that into my calculator. I get T equals 0.33. What should my units be? Again, this is pretty tricky. Take your time right now to decide what the unit should be for the time it will take Miss Sarah to bike to school. So hopefully you looked back at our original units for the speed. They're in miles per hour. So that means that any time that speed is talking about or is measuring is going to be in hours. Woohoo, hours. Another way you can figure this out, and this one is a little bit more annoying, but it works, is that you can say, 15 miles on top. These guys, words are hard. I've got miles on top. I've got miles on bottom. Just like in math class. Same thing on top, same thing on bottom. They'll cancel out. And then we have these hours left in the denominator of the denominator, which actually ends up being the numerator. Algebra is pretty sweet. So we end up with hours as our units. This algebra part sometimes is very confusing. So if you're like, wait, Ms. Getz, what did you just say? Just ignore it. Move on. It's cool. Figure out what units to use from the units that are used in speed. Since it's a time, we look at what time units speed has inside of it, and in this case, it's hours. Okay, so we've done 2 example problems so far. I'm actually going to do 2 more example problems with you from your problem set, but I wanted to review what we've learned so far. So we now know how to calculate distance or time and how to use that calculation with our problem-solving template and how to decide which equation that we're going to use. So up next, we're going to do the first 2 problems in our problem set, and I'm going to show you something pretty nifty on notability.